Hey guys, welcome back to my series where I'm solving LeetCode problems from scratch. Now I'm solving the 190 reverse bits. I tried solving it before, I didn't understand the problem. I'll be honest with you, I had no idea what was expected. I thought we had to convert the string, reverse things. It wasn't really the thing, so I had to do some Googling and I learned some things that I had no idea that I could do. But I'm going to share them with you. So, reverse bits of a given 32-bit unsigned integer. So the input, they say it's this, but it's not really this. It's a number. It's not a string with this. It's the number corresponding to this. But these are 32 bits, and it's important to know. And the output is the reverse. So you can see that it's 00111, 00111. So how do we do that? Well, I just learned something which is like a bit operations in Python. So let me show you. So let's say you want to know, you have the number 10, number 11, and you want to know if the number 11 is even or odd. Well, you can always go and do 11, rest of the division of 2, and this will tell you if it's even, if it's odd, that it's odd, and this will tell you that it's even, because the rest is 0. But one thing you can do is you can go 11 and 1. And how does this work? I didn't know this. So the number 10 in binary is, so ends with a 0, then it's how do you do 10 in binary? I think it's 1, then 1. Looks like this. So this is 0, 2, 4, 8. Actually, 1, 0, 1, 0. 10 in binary. 1, 0, 1, 0. 1, 0, 1, 0. I don't really work with binary that much, so. Okay, so this is equals number 10. And what is number 11? Number 11 is 10 plus 1, so it's 1, 0, 1, 1. It's this difference. So whenever you do, this is what I didn't know. If you're doing 100 and if you're doing 10, which is number 10 decimal, and 1, basically what it's saying, it's checking the all the the bits and comparing them. So 10, we know that it's 1, 1, 0, 1, 0, and 1 is 0, 0, 0, 1. So now let's do the logic, the AND logic. 0 and 1 is 0. So 1 and 0 and 0. 0 and 0, 0. 0 and 1, 0. 0 and 1, 0. And if we come here and try 0 and 1 is 0. But if we want to do 11 and 1, which is 1, 0, 0, 1, 0, 1, 0, 0, 0, 1, then 1 and 0, 0, 0 and 0 is 0, 1 and 0 is 0, 1 and 1 is 1. And that's why it works like this. So what if we did 10 and 2? So let's do 10 and 2. This is 10. This is 2. So 1 and 0. Oh, sorry. 0 and 0, 1 and 1. So 10 and 2 will be 2. Well, I didn't know that we could do that. And that's pretty cool. So that's if we want to know which bit is the bit on which bit is the last bit, we just do AND 1. And it will be 0 if it's a 0, and it will be 1 if it's a 1. So let's go and do some coding. Yeah, I had no idea what I had to do. This is my previous code. So what we actually need to do is let's create a final int, which is an integer equal to. And now we want to reverse bits. So basically, if we have 32 bits, which is, let's say, 1 0 0 0 0 1 1. Reverse it. Reverse is 1 1 1 1 0 0 0 0 1. So we pretty much want to check. My strategy will be, let's check the last digit, the last bit, and then let's put it in the beginning. And how do we do that? First, let's check the last bit. So n and 1. So the bit is this one, n and 1. And then we can do final int equals final int. And what do you have? You have the and you have the or bit. So what does the or do? The or is similar, but let's say we were doing 11 and 1. If it was 11 or 1, it would be 1 and 0 is 1, 0 and 0 is 0, 1 and 0 is 1, 1 and 1 is 1. So this is 2 plus 4. No. 1 plus 2 plus 8. So it's 11. So 11 and 1 is 11. 11 or 1. 11 or 1 is 11. Exactly. Pretty cool. So that's how we change the bits. So that's one way of adding a bit. And we know that we're starting with an integer which is 0. So it's just a lot of 0 bits. So we're just going to add the bit to the right place. So how do we add the bit to the right place? This is the tricky part. So what we can do is we can shift it. And if we shift it like this, and we shift it to the 31st position, then we just put it in the beginning. Because we have 32 positions, well, counting with 0, so the last one is 31. So we just shift it back like this. And now we just put the bit in the first position. And just to show you how this works, let's say we wanted to do, so this is number 10, which is 1010. And the number 0101, this is number 5. And this is like this, I've just shifted 1010 to the right. And I removed the last 0. So 10 shifted 1 step to the right is 5. And this is the same as dividing by 2. But yeah, this is something that works. I have no idea. So I'm just gonna shift it this way, 31. Okay, I just did it for the first bit and put it on the last position. But what if I want to do it for all of the bits? So now I do a for loop for I in range 32. Yep. And then I do a bit of n, and now I shift n to the right. Because let's say I want the second bit, then I need to shift it to the right. And in the first time, I don't need to shift it to the right, I will be 0. In the second iteration, I need to shift it to the right once, I will be 1. Cool, then I shift it, and the same thing here. And the first time I want to shift it all the way. The second time I just want to shift it 30. So I subtract 1. So I just need to subtract I. And then I return final int. I hope my explanation made sense. Submit. Great. Hope you guys liked it. See you later.